In this video, I will explain why separational variable works. So usually the form we start with is dy over dt equals f of t over g of y. And if you watched the previous video in this series, our equation was of that form because we had dy over dt equals 4t minus t squared over 4 plus y cubed. Then, if you cross multiply and use a separation of variables trick, then you get gy dy equals f of t dt. And again, the whole point of separation of variables is to integrate both equations, f of t dt. And then we basically obtain the equation g of y equals capital F of t plus a constant. Where here, f and g, they're antiderivatives. Of f and g. And this is how we obtain that implicit equation from the previous video. And in particular, what this gives us, it gives us an equation for y. And what I'm claiming is that this y solves our differential equation. So claim this y solves our ODE. ODE dy over dt equals f of t over g of y. And why is that true? You just start with the equation and use a chain rule. So why? Take our equation, g of y equals f of t plus c, and then differentiate. So g of y prime equals f of t plus c prime. And then using the chain rule, you get g prime of y times y prime equals f prime of t. But capital G is an antiderivative of little g. So you get g of y dy over dt equals f of t. And then in the end, if you solve for dy over dt, you get f of t over g of y. So in fact, the y we found in our equation solves our ODE. ODE. That's all she wrote. That's how separation of variables works.